carbon dioxide moves out on exhalation. There are literally millions and millions and millions of thin balloon-like sacs inside of the lungs. That's what alveoli are. And the whole purpose of those is to allow, they're semi-permeable. So only certain things can get across. Not everything, only certain things can get across. All right? And they're surrounded by blood vessels known as pulmonary capillaries. Pulmonary capillaries. Okay? You may want to highlight it, write it down, what have you, because this is the place that exchange takes place, is at the pulmonary capillary. Okay? So the oxygen goes from there to the heart to be distributed to the body. Okay? So the oxygen comes into there, crosses over onto the pulmonary capillary, goes back through the pulmonary what? To the heart. The only one of these in the body that carries oxygenated blood. The pulmonary, come on. Y'all remember? Which one carries deoxygenated blood? It's
Deoxygenated?
Yeah, which one carries deoxygenated blood?
Veins?
The pulmonary, normally yes, but it's the reverse. So the pulmonary vein carries oxygenated blood back to the heart. Okay? So it goes from the pulmonary capillary to the pulmonary vein, and it carries oxygenated blood. That is the only vein in the body, that carries oxygenated blood is the pulmonary vein. Okay? The only one in the body. At this site also, carbon dioxide comes off of the pulmonary capillaries and into the alveoli. It literally is a switch. They happen at the same time. Oxygen goes on, CO2 moves out. Okay? Oxygen comes in, CO2 moves out. And it's exhaled and removed from the body. Okay? And remember, it attaches to the what? Oxygen attaches to what? Well, they go through the alveoli and attach to the what?
Blood.
What type of blood? What part of the blood?
The, that funny word.
Hemoglobin?
Yeah, that one.
There you go. Okay. It attaches to the hemoglobin on red blood cells. Okay? You're going to need to know that.
Oh, that's right, because that's the piggyback.
That's the piggyback. There you go. So again, got to remember, got to use something to help you remember it. That's exactly what it is. It's the piggyback ride. Okay? So we talked about the mediastinum when we talked about anatomy and physiology. And this is what that mediastinum is. This is the middle of the chest. Okay? This is where the major vessels are. This is where the heart is, the esophagus, the trachea, the major bronchi, a ton of nerves. All those things are right there in the center of the chest. So we're talking about the vena cava, both inferior and superior. We're talking about the aorta. We're talking about the diaphragm itself. We're talking about the bronchi. Okay, so when we look at it, it looks like the majority of the thoracic cavity, but truthfully, it's just that stuff right there in the middle is the stuff we're worried about. Okay, not so much the lungs, but the stuff right there that runs along the middle. All right, and the important thing to know about that is the reason those are so important is that these are the things that sustain life. Those are the main portions of the body that sustain life. Okay. The other thing that is in there, and it talks about many nerves, but the main nerve that's in there that runs along the mediastinum is one called the phrenic nerve. Phrenic. Phrenic nerve. Okay? This is the one that allows the diaphragm to expand and contract. Okay? That's important. We're not breathing without it. Remember we talked about what area of the body cervical vertebrae are affected if the diaphragm stops working? C3, 4, and 5. Remember that. If C3, 4, and 5 are damaged, your diaphragm won't work. Okay? C3, 4, and what we use to remember that is C3 through 5 to stay alive. Okay? C3 through 5 to stay alive. That's why we protect him. If you have somebody that's been involved in any sort of significant injury to the cervical spine or thoracic spine, you collar them, because it's better to collar them and them not need it than to not collar them and then be a vegetable. Specifically one that has to be on a ventilator for the rest of their life. If we can prevent it, we do our best to prevent it. Okay? So how does breathing actually happen? Well, when we talk about the physiology of breathing, we're talking about the respiratory and the cardiovascular system and how they work together. It's interesting that if you look at an EKG, and you look at the waveform of an EKG, and you look at the waveform of your pulse ox, they're actually very, very similar. They fall along almost the same line. Well, the reason for that is those two systems begin in the same place in the body. Okay, they both begin back here in the pons and the medulla, what's called the pneumotaxic center. Okay, that's where breathing comes from. Pneumo, breathing, right? Heard it before? Okay, and so what happens with this is the purpose of it is to make sure that we have a constant supply of oxygen. We have to have a constant supply of oxygen and nutrients that go to the cell, or what I like to refer to as the end user. The easiest way to think about that is the brain and the heart are like toddlers. Okay? The brain and the heart are like toddlers. This is the way I remember this. If the brain or the heart doesn't get the oxygen and nutrients that it needs, because the brain needs sugar and the brain needs oxygen. The heart just needs oxygen. Okay? If they don't get the oxygen or nutrients that they need, what's going to begin to happen is they're going to throw a tantrum. Well, the beginning of that tantrum is with the brain that you're going to go from being normal to being anxious. The more oxygen you're depleted of. You're going to go from anxious to being agitated. You're going to go from agitated to altered, and then altered to unresponsive. Okay? So if you think about it like that, what happens to a toddler? Well, toddler loses his blanket or loses his pacifier. First they're going to cut up a little bit, they might be a little whiny. After a while they're going to start crying. Then they're going to start crying and they're going to throw a fit and probably be laying out on the floor. Then they're going to be laying out on the floor throwing a full-on tantrum. And then what are they going to do? They're going to cry themselves to sleep. So that's exactly what happens, just like those steps with the brain and the heart. So what does the heart do? Conversely, the heart will say, at first, heart's normal. A little bit of oxygen deficiency, what's the heart going to do? Well, it's going to start throwing some irregular beats. The longer it's without oxygen, the more irregular beats it's going to throw. Eventually, it's going to throw some extremely irregular beats and put you into cardiac arrest, and then ultimately it's going to stop. Okay? So again, normal, anxious, agitated, altered, unresponsive. Okay, those are the 5 phases through which you go through in the instance of being oxygen deficient. Okay? Normal, anxious, agitated, altered, and unresponsive. Thank you. I got my A's mixed up. Okay. Alright. So, also, this respiratory system takes the carbon dioxide out. And the easiest way to think about this is carbon dioxide is the poop of the body. Okay? The poop of the respiratory cycle. So it's nothing but waste. It's the end product of the oxygen we take in. After oxygen is used, the body produces carbon dioxide and says we don't need that. Okay? That's the waste. That's the end result of everything that we've taken in. Okay? For lack of a better way to put it. Kind of crude, but I guess you understand that. Okay? And if you think about it like that, you understand why it's so important to get carbon dioxide out of the body. Because what happens when your bowels back up? Your body becomes toxic, right? If you're not getting rid of all the waste that are within your bowels, your body becomes toxic. Okay? And what happens when your body becomes toxic is the body begins to say, hey, that waste is still there. Maybe there's something else there we can use. And so it tries to go back and recollect whatever's in there because it's not supposed to be sitting in the gut for any period. So again, Carbon dioxide, same thing. The body's going to try to reuse it if it's still in there. So that's why it's so important for us to get it out. Okay? But the body can't reuse carbon dioxide. That's the problem. The only time that you'll see that is in the instance of COPD patients, where they breathe off of a hypoxic drive. And so CO2 is the way in which their body breathes, because that becomes their new normal. Okay? And we'll talk about that later when we get into to full on into respiratory. Okay? So there are 3 processes involved in breathing. 3 processes, and this is the physiology behind how we breathe. That is ventilation, oxygenation, and respiration. Ventilation, oxygenation, and respiration. It's right there in table 10.1. But not only am I going to explain it, I'm going to expound upon what they have there, because there's more to it than just that. Okay? A lot. Ventilation is the actual process of air moving in and out of the body. Okay? This is air moving in and out of the body and into the lungs. So that's everything coming all the way down to the point of it getting into the lungs. Alright? That's your ventilation. That's what we refer to as breathing. Okay? Then you have oxygenation. Now the difference is with oxygenation, this is the diffusion and the osmosis, right? This is the oxygen moving on to the hemoglobin, carbon dioxide moving off. Okay? So the oxygen moves on to the hemoglobin in the bloodstream. Takes a ride. Alright? Again, piggybacking. Just the way Will said. Alright? From there you have your respiration. Now the difference is oxygenation is the molecules getting onto the hemoglobin. Respiration is at the end user. You know, when you log into Microsoft products and anytime you get a new one, it always comes up with that end user license agreement. You're the end user, you're the person this was made for. That's what your heart, liver, lungs, all your major organs are, is that end user. The person who that oxygen was sent into the body for it to use. Okay? So we have to make sure that this stuff is getting to those end users. And so the actual exchange of oxygen and carbon dioxide, not only in the alveoli, but at the tissue within the body. So as that oxygen moves from the capillaries into each organ, once it gets to that organ, there's another gas exchange. Oxygen goes on, carbon dioxide comes out. And then that hemoglobin carries that back out back to the lungs to be moved out the body. See? So therein lies the process. Ventilation, air comes in. Oxygenation, oxygen moves on to the actual hemoglobin. And then respiration, and in the respiratory cycle is actually the exchange of carbon dioxide and oxygen, both at the alveoli and at the tissue. Okay? At the tissue. That's the most important part. It's one thing for it to happen at the alveoli. That's where it needs to happen initially. But the most important part is that it comes out of your organs. Because if carbon dioxide doesn't come out of your organs, you're going to develop infection. You're going to develop excessive bacteria. That waste is going to build up. It's going to make you markedly sick. Okay? So, what happens with ventilation, we'll talk about them in sections here. Okay? What happens with ventilation is just the opposite of what you think. The diaphragm actually contracts and uses negative pressure. So it pulls on the fact that there's more oxygen outside and the pressure outside the body is greater than the pressure inside the body. So it pulls up, tightens up, and as soon as it tightens up, that pressure inside the body is lower than outside, so air just naturally flows in. Okay? It is an active process. Okay? And then for us to breathe out, the diaphragm just relaxes. It lowers and the oxygen just moves out because it's free to leave. Okay? Or excuse me, the carbon dioxide moves out because it's free to leave. Let me correct that. Okay? So the diaphragm contracts, moves really the opposite of what you think it would. The diaphragm contracts, and then like I said, through negative pressure, it pulls air in, okay? And then, when it relaxes, drops back down to the bottom, CO2 moves out. Because gas exchange, all that stuff that we just talked about happens, and then everything moves out in one foul swoop, okay?
So pretty much in a way, it's like drafting.
Yes.
I mean, it's almost
Using
exactly-
negative pressure,
it's
yes.
almost exactly like drafting.
The impellers inside the pump actually pull the water into the pump, and once you create a vacuum, that vacuum is constant.
Right.
Yes, exactly. So, good example. Got to use what you know, right? It creates a negative pressure vacuum, and that's what allows for that water to flow into your vehicle. That's correct. Okay. So, the chest has to move, and the supporting structures have to expand. So the chest wall expands, the diaphragm contracts, the chest wall expands. Okay. And this allows for that active process to take place. The muscles of the intercostal, so the muscles in between your actual ribs, tighten too. Those, the diaphragm, all those muscles within the chest tighten, and then as the air moves in, it allows the chest to expand. Okay. What we talk about when we're referring to oxygenation is something called PaO2. Okay. PaO2 has to do with partial pressure. The reason we talk about partial pressure is the partial pressure of oxygen that is lower than the partial pressure of carbon dioxide. This is what causes that gas exchange to take place. Okay? Remember osmosis and diffusion. Okay? Area of greater concentration to an area of lesser concentration. So oxygen moves where it's not, CO2 moves where it's not. And that's what constantly causes that gas exchange to take place. Okay? Is those changes in partial pressures. Diffusion is the process that this happens by. Diffusion. All that stuff you learned in chemistry and biology that you thought you'd never use again, you're welcome. Alright? So what happens is these diffuse until that partial pressure equalizes. No different than, like you said, talking about your pump. What happens? You're going to continue, if you're drafting, and you have that pump, right? You have to equalize the pressure between the two, correct? Between what you have from your water source and what you have coming into your truck, or if you're doing multiple pools, you have to equalize the pressure between the two pools, or the amount of water within the two pools, in order to get them to siphon. Okay? If you have one full pool that's overly full, what's it going to do? Suck from one into the other until they're both equal, and then they drop at the same time. And that's how you keep that pressure, or that partial pressure. Okay? Because if one gets too low, what's going to happen?
Cavitate.
You're going to cavitate. Okay? And you're going to cause yourself more harm than good. You're going to lose pressure, and the exact same thing happens in oxygenation. You're going to create a vacuum. You're going to create a negative vacuum, so much so that you're not going to be able to pull oxygen in. And that's what actually happens in COPD. They have so much CO2 that their body begins to breathe based off how much CO2 they have, not how much oxygen they have. Okay? And that's why you see them always sucking wind, is because of the fact that their body just believes that they're constantly in the state of hypoxia. So they're constantly trying to breathe a little faster, breathe a little deeper, and their body is literally fighting against itself. And that's exactly what's happening, is you're almost jet siphoning, trying to pull air in, for lack of a better way to put it. Right? Okay. I never would have thought to use that actually, but I like that reference. It works for me. Okay. So, like I said, inspiration delivers oxygen to the alveoli. Okay. So not all inspired air reaches the alveoli for gas exchange. You do have an area called dead space. Now, when we talk about dead space is the area here. Everything above the trachea to the open airway. Okay. This is not going to get used. It's there. If we needed to get it down there, we might be able to get some of it, but it's about 15% of the inspired air that we take in. Okay, with every breath, about 15% of it doesn't get used. Okay, that's called dead space. All right. Then we have something called tidal volume. T-I-D-A-L, no different than the tide out there, Tybee. It's just cleaner. And what tidal volume does is, tidal volume is the measure of how deep your breath is. The average adult takes in between 500 to 700 milliliters or cc's of air, cubic centimeters of air with each breath. Okay? 500 to 700. Your book says, I believe, 500. Okay, larger patients take in 700.